Okay, we're continuing to work partial fraction decomposition problems. All right, so this problem here, the first step is we see is the order of the numerator less than the order of the denominator, right? Because with partial fraction decomposition, we're strictly working with rational functions, rational expressions, which is a rational expression is just a ratio of polynomials. So is the order of the polynomial in the numerator less than the order of the polynomial in the denominator? In this case, it's not. So since it's not, we're going to need to first do polynomial long division. All right, so let's do that. And if you need to brush up on polynomial long division, go earlier in the playlist. I think it was chapter 3. Those videos might not be posted yet, but they'll be posted soon. Okay, so let's write in the dividend and put any placeholders if we need, like 0 placeholders, but it looks like we won't need that here. Okay, now let's put in the divisor, and we'll put in some 0 placeholders. Okay, x to the 4th divided by x cubed is x. Now multiply x by the divisor. Get x to the 4th minus 0x cubed plus. Okay, now subtract these two expressions. Minus 4, 11 minus 2, minus 13. Okay, now bring down the 12. Okay, minus 4x cubed divided by x cubed is minus 4. Multiply minus 4 times the divisor. Subtract these two expressions. Minus 13 plus 8 minus 5. Okay, so we've got x minus 4 plus and 9x squared minus 5x plus 12. Okay, so now here we've got a rational function where the degree of the numerator is less than the degree of the denominator. So we're going to do partial fraction decomposition on this expression. So, okay. So first step with partial fraction decomposition, once you verify that the degree of the numerator is less than the degree of the denominator, not less than or equal to, it needs to be less than, then the first thing you're going to do is you're going to factor the denominator, fully factor the denominator. And so by fully factor, what I mean is, so it's known in math that any polynomial, no matter what it is, any polynomial can be factored all the way to the point that you're left with the only factors are linear and quadratic factors. Either all linear, all quadratic, or some combination of those. So linear factors, so ax plus b is a linear factor to any positive integer power, 1, 2, 3, whatever, and then ax squared plus bx plus c is a quadratic factor to any power. So you can take any polynomial and factor it into one or more factors that are like this. Okay, so that's the first thing we want to do. We're going to factor the denominator. Okay, now If you don't remember how to factor, then go back to the earlier in the playlist, chapter R, in the pre-algebra, the first chapter in the algebra playlist, and we went in full detail into factoring. Okay, so we see we can take out an x. Okay, and then that's fully factored. I mean, we can't, there's nothing more we can do here. Okay, and you can see we've got a linear factor here. This is, so ax plus b, this is a, where a is equal to 1, b is equal to 0. And then we've got a quadratic factor here, where a is equal to 1, b is equal to 0, c is equal to 2. Okay, so now you factor the denominator, and you don't do anything with the numerator. Just leave the numerator. Don't even worry about it. And now we're going to write out the form of the decomposition. And same idea. We're completely ignoring the numerator here for the even at this step. With factoring, we were ignoring the numerator. And now even at this step, writing out the decomposition, the form of it, we're going to ignore the numerator. So all we do is, to write out the form, we just go to each factor. Each factor is going to have its own associated form with one or more terms associated with it. Okay, so we come first. Here's a linear factor. Okay, this is a linear factor to the power 1. So with a linear factor to the power 1, you just put that linear factor in the denominator and put a constant in the numerator. And now you're done. You're done with this factor. Okay, now we have this quadratic factor to the power 1. All you do here is you write the quadratic factor in the denominator, and then in the numerator you put constant times x plus another constant. And you know all these constants are different. Okay, and now we're done with this factor, and that's the last factor, so we're done. We're done writing out the form of the decomposition. So now we just need to solve for the a, b, and c. And to do this, we clear the fractions. First step is to clear the fractions. Multiply by the least common denominator. And so we've got 9x squared minus 5x plus 12 is equal to okay, now you can choose one of two methods, or you can kind of combine both of these methods to get the coefficients. You can choose x's, and then once you've chosen an x, you input the x, and then you can just move around solve for different constants. Or you can also you can distribute all this and then group the x squareds together, the x's together, and then the constants together, and equate those to the coefficients on this side. So you can do whatever you want, but I see, okay, let's do, if we say x is equal to 0, then we get what? So 12 is equal to 2a. So a is equal to 6. That was pretty quick, right? And so, okay, so I guess now let's distribute everything. So minus 9x squared minus 5x plus 12 is equal to, so 6x squared plus 12 plus bx squared plus cx. So we've got 6x squared plus bx squared plus cx plus 12 okay, so 6 plus b plus cx. Okay, so we can see c is equal to minus 5, and then we see that 6 plus b is equal to 9. So b is equal to 3. Okay, so A is equal to 6. Bx plus C is equal to, so 3x minus 5. Okay, so we'll replace that here. So plus 6 over x plus 3x minus 5 over x squared plus 2. And there you go. That's the decomposition. Okay, step 1, check to see if the degree of the numerator is less than the degree of the denominator, and it is in this case. Okay, next, you want to fully factor the denominator. And so if we look closely here, we can see that this is x squared squared plus 10x squared plus 25. And so this is a perfect square trinomial of the form x squared plus 5 squared, right? X squared plus 5 times x squared plus 5 is x to the 4th plus 5x squared plus 5x squared is 10x squared plus 5 times 5 is 25. So, you know, again, we're not even looking at the numerator. We know it's a polynomial. We know what it is, but we're not, in these initial steps, we're not even considering it. So we've got let me write it down here. So okay, now that's fully factored, right? We can't, there's nothing more we can do with x squared plus 5. Okay, now so it's done, it's fully factored. So what, you know, again, we can take any polynomial and factor it into a product of strictly linear and quadratic factors. So what is this? Well, it's just a single quadratic factor that's raised to the power 2. So remember, we said we could take any polynomial and separate it into factors of linear factors to any power of positive integer power, 1 greater than or equal to 1. And same thing, any quadratic factor to any positive integer power greater than or equal to 1. This is a quadratic factor with a equal to 1, b equal to 0, and c equal to 5, and n equal to 2. Okay, so next step is we write out the form of the decomposition, and again, we're completely ignoring the numerator, even at this step. Okay, so how do we write out the form of the decomposition for a quadratic factor to a power other than 1? It's the exact same concept as the linear, what you do for the linear factors raised to a power other than 1. In that, so we're first going to write out, okay, we do the quadratic factor raised to the power 1. Okay, now, but we don't, for a quadratic factor, we don't put a constant. We do like this, ax plus b. Okay, and then, okay, but for a linear factor raised to the power 2, we would do that linear factor squared, right? Well, we're going to do the quadratic factor squared. And then here, for the linear factor, what would we do? We just put another constant. Well, here, we're just going to put another constant times x plus b, but it's different constants. And that's it. Now, that's how you decompose this quadratic factor squared. So now we just need to solve for the a, b, c, and d. And so to do this, you multiply to clear the entire equation by the least common denominator to clear the fractions. So this is x squared plus 5 squared. So we've got ax plus b, and then x squared plus 5, and then cx plus d. Oh, and I forgot to write, yeah, so okay, I can put it on this side. 2x cubed minus x squared plus 13x. Okay, so, you know, you can, it looks to me, we could choose some x's here, but it looks like it'd just be easier to go ahead and just group these. So let's do that. So we've got ax cubed plus 5ax plus bx squared plus 5b plus cx plus d is equal to 2x cubed minus x squared. Okay, so we've got ax cubed plus bx squared plus, and then 5a plus cx plus 5b plus d. 2x cubed minus x squared plus 13x. Okay. All right, so we can see that a is equal to 2, b is equal to minus 1, okay, and then 5a plus c is equal to 13, a is equal to 2, 10 plus c is equal to 13, c is equal to 3. Okay, now we've got 5b plus d is equal to minus 5, minus 5 plus d is equal to minus 5, so d is equal to 0. And there we go. So this is equal to, and then 2x minus 1, and then that's it. That's the decomposition. Okay, first step, check to see if the order of the numerator is less than the order of the denominator. In this case, it is, because you can see this, the order of the denominator is 3. Okay, then from there, you want to factor the denominator, and it looks like it's already factored here. So we've got a linear factor here, a quadratic factor here. We can check to see if this quadratic factor can be factored further using the discriminant. So b squared minus 4 times a times c is negative. So the discriminant is negative, so this can't be factored anymore, at least with factors that have integer coefficients. Okay, next step is to write out the form of the decomposition. So we go one factor at a time. So, okay, this linear factor here to the first power, that's just, you put the factor in the denominator and then put a single constant in the numerator. Quadratic factor to the first power, you put the quadratic factor in the denominator and then put a constant times x plus another constant in the numerator. And that's it. Now we need to solve for those constants. Multiply by the least common denominator. Okay, so we've got okay, and then okay, so, you know, we can set, I'm noticing here we can set x equal to 4 and get a, so why not do that? Okay, so 4 times 4 is 16. 16 times 5 is 80. minus 16 plus 8. This goes to 0, and then we've got 16 plus 4 plus 4. 80 minus 8 is 72. And then 16 plus 4 plus 4 is 24. 24 or 72 divided by 24 is 3. Okay, so let's set x equal to 1. No, x equal to 0. Okay, so you've got 8 is equal to 4a plus c times x minus 4, so that's minus 4c. Okay, so 4c is equal to 4. C is equal to 1. Okay, now let's set x equal to 1. So we've got 5 minus 4 plus 8 is equal to 3 times 1 plus 1 plus 4 plus b plus 1, and then there we go. So equals to, okay, so now we've got minus 3b minus 3. So 3b is equal to 18 minus 3 is 15 minus 9 is 6. So b is equal to 2. All right, so a is equal to 3. B is equal to 2. Bx plus c, so 2x plus 1. And there you go. That is the decomposition. Okay, we want to first check to see is the order of the numerator less than the order of the denominator. It is. Okay, now we want to factor the denominator into just strictly products of quadratics and linear factors. And so this isn't a quadratic, right? A quadratic is x squared plus bx plus c. This is x to the 4th. So we need to factor this. Okay, so, you know, if this was x squared plus 5x plus 6, then it would be, no, it would do this. Okay, so here then we would do, in that case, what we need to do is, so, okay, we've got x to the 4th plus 5x squared plus 6. We want to say u is equal to x. So that, in that case, or no, u is equal to x squared. So u squared is x to the 4th. And so what we have here is u squared plus 5u plus 6. Right? This is the method we used to factor something like this. You make a substitution. Okay, so you have u plus 3, u plus 2. All right, and now we substitute back. So x squared plus 3, x squared plus 2. And that is how you factor this. And so we've got 4x cubed minus 4x squared plus, okay, and then okay. And so this is fully factored. We can't factor either of these anymore. I mean, these are quadratic factors. Ax squared plus bx plus c, both of these have the b coefficient is equal to 0. Okay, so we've got two quadratic factors. Now we need to write out the form of the decomposition. We're just looking at, we just factored the denominator, and now we're going to make the form of the decomposition strictly looking at the denominator. We'll go one factor at a time. So both of these are to the first power, so we're just going to, okay, so the first factor, we just put x squared plus 3, and then ax plus b, and we're done because it's to the power of 1. And then the next factor, we do the same exact thing. Cx plus d. Done. It's to the first power. Okay, so now we need to solve for a, b, c, and d. Multiply by the least common denominator. So we've got 4x cubed minus... Okay, so all right, plus cx plus d. Okay, so can we input something and get a quick and solve for a quick constant? Input an x and get a quick constant. If we said x is equal to 0, it looks like we could get an easy equation for b and d, which we might come back and do that. We'll see. But let's just go ahead and let's just distribute all of this and combine the like terms. So, okay, so we've got ax cubed plus 2ax plus bx squared plus 2b plus cx cubed plus 3cx plus dx squared plus 3d. Okay, so 4x cubed minus... Okay, so you've got ax cubed plus cx cubed plus bx squared plus dx squared plus 2ax plus 3cx plus 2b plus 3d. Okay. So we've got a plus c x cubed plus b plus d x squared plus 2a plus 3c plus 2b plus 3d. Okay, and so now we can set these coefficients equal to the corresponding coefficient. And, you know, we could say, come back here and say x is equal to 0. Well, we could do that here. If we said x is equal to 0, yeah, we could do that here. If we said x is equal to 0, we'd get, there's the equation, 2b plus 3d is equal to minus 7. So, okay, well, all right, we don't need to, we have everything we need here. So, right, so a plus c is equal to 4, b plus d is equal to minus 4, 2a plus 3c is equal to 11, 2b plus 3d is equal to minus 7. All right, so to solve this, let's just choose some cleverly choose equations to combine. So, okay, we can do we have a b and a d and a b and a d and an a and a c. Okay, yeah, so we could just, okay, we can do we have two equations, two unknowns here. Yeah. Yeah, so, all right, you have b plus d is equal to minus 4. Then you've got 2b plus 3d is equal to minus 7. Let's solve for b and d. So if we multiply this by 2, we get okay, now let's subtract these two equations. 2d minus 3d is minus d. Minus 8 plus 7 is minus 1. So you get d is equal to 1. If d is equal to 1, then 2b plus 3d is equal to minus 7. You have 2b plus 3 is equal to minus 7. 2b is equal to minus 10. b is equal to minus 5. Okay, now we've got a plus c is equal to 4. 2a plus 3c is equal to 11. Multiply this by 2. Subtract these two equations. 2c minus 3c is minus c. 8 minus 11 is minus 3. C is equal to 3. Okay, now 2a plus 3 times c is equal to 11. 2a is equal to 2. A is equal to 1. And there we go. So ax plus b, x minus 5, cx plus d, and then that's it. That is the decomposition. Okay, first step, check, is the degree of the numerator less than the degree of the denominator? In this case, it's not. So we need to start by doing polynomial long division. Okay, so, all right, we've got, so 2x cubed minus, okay, we don't need to put any placeholders there. And then x squared minus 3x. Okay, 2x cubed minus x squared is 2x. Now, 2x times the divisor is 2x cubed minus 6x squared minus 20x. Let's subtract these two. Okay, minus 11x squared plus 6x squared is minus 5x squared minus 4x plus 20x is 16x. Okay. All right, minus 5x squared divided by x squared is minus 5. Minus 5 times the divisor plus subtract these two. 16x minus 15x is x. 24 minus 50 is minus 26. All right, and so this is equal to 2x minus 5 plus okay. And so now we have a rational function to where the order of the numerator is less than the order of the denominator. So we're going to do partial fraction decomposition on this. Okay, first step is you factor the denominator. Okay, so let's see. X, all right, minus, yep, there we go. Okay, so we've got these two linear factors. So now we want to write the form of the decomposition. This is simple, with two linear factors raised to the first power. Okay, now clear the fractions. Okay, so we've got x minus 26 is equal to a plus okay. So we could just say, all right, x is equal to minus 2. We've got minus 28 is equal to minus 7b. So b is equal to 4. And then if we said x is equal to 5, you've got 5 minus 26 is minus 21. Okay, so a is equal to minus 3. Okay, so all right, and now let's put that here. Take this, we need to put a minus. So minus there we go. Okay, last problem. Check, first step, check, is the order of the numerator less than the order of the denominator? In this case, it's not. So let's do polynomial long division. 3x cubed plus 2x squared minus x squared plus 2x plus 1. All right, 3x cubed divided by x squared is 3x. Multiply 3x times the divisor. 3x cubed plus 6x squared plus 3x. Subtract these two terms. 2x squared minus 6x squared is minus 4x squared. Minus x minus 3x is minus 4x. Okay, minus 4x squared divided by x squared is minus 4. Multiply this, minus 4 times the divisor, so minus 8x. Okay, subtract these two. You've got minus 4x plus 8x is 4x. Minus 5 plus 4 is minus 1. Okay, so we've got 3x minus 4 plus okay. Okay, now we want to, with polynomial long division, we've created a polynomial that where the order of the numerator is less than the order of the denominator. So let's do partial fraction decomposition on this rational expression. Okay, first step, you factor the denominator. It looks like we've got an x plus 1 squared, x squared plus x, yep, okay. Okay, now we need to write out the form of the decomposition, and we've got a, so this is a linear factor squared, so we do just put the factor to the first power over a single constant, then put that factor to the second power over another constant. Okay, now let's clear the fractions. Multiply the entire equation by the least common denominator. So we've got a. Okay, so when x is equal to minus 1, you've got 4 times minus 1 is minus 4. So b is equal to minus 5. Now when x is equal to 0, you've got minus 1 is equal to a minus 5. A is equal to minus 1 plus 5 is 4. Okay, so four. Okay, so we've got and that is the decomposition.